Okay, so I'm gonna integrate the integral of e to the power 3x sine 2x. When you have the integral of the product of two functions, and you won't be able to use any u sub. If you let u to be the 3x, it's not gonna give you sine 2x. So at this point, I need to use integration by part. So I'm gonna perform the regular integration by part. So yes, follow the lead, right? I'm gonna let my u to be the trigonometry and then my dv to be exponent. So I'm gonna let u be the trigonometry sine 2x, and then the dv part is the part that where we're gonna take the integral. So sine 2x dx. So this is, oh, no, I'm sorry, e 3x dx. Okay, so this is my dv and this is my u. All right, so now for the u one, it means you're gonna take the derivative. I will have du equal to cosine 2x dx. And my v is where I'm gonna take integral both sides. So v gonna be 1/3 e 3x. And then we're gonna do uv minus integral of v du. So integral e 3x sine 2x dx is equal uv u times v. U times v is same as sine 2x times 1/3 e3x. So I'm gonna have 1/3 e3x times 2x minus integral of what? V du. And my v is 1/3 e to the power 3x. So I'm gonna have 1/3 e to the power 3x times 2. So end up we have 2/3. 2/3 e 3x cosine 2x dx. Now I'm gonna, for the regular integration by part, usually we can integrate here already directly. However, in this integral, I still end up having the exponent and the trigonometry. So in order to complete this problem, we need to integration this one more time. So we need to integrate again. Integrate by part again. And I'm gonna let u equal e3x, and oops, u equal cosine 2x, and then dv is e3x dx. Taking derivative of cosine 2x, we have du is -2 sine 2x dx, and then v gonna be 1/3 e3x dx. And now we're gonna do the uv minus vdu. So I will have uv, which is 1/3 e 3x cosine 2x. Okay, uv 1/3 e 3x cosine 2x minus, but there's a negative right here, so that becomes plus 1/3 e 3x times 2, so it's gonna be 2/3 integral of 2/3, and then that's gonna be e3x sine 2x dx. Okay, and then don't forget on our expression here, there's a 2/3 right here that I didn't carry in. So we need to put down the 2/3 in the front, so and the negative. So it's gonna be -2/3 times this whole thing. So now my integral now will become 1/3 e3x sine 2x minus, if I distribute the 2/3, I have -2/9 e3x cosine 2x. And then I distribute this, I'm gonna have -4/9 integral of e3x sine 2x dx. I actually bring the 2/3 to the front of the integral, just like this one, I bring it to outside. And I just take the integration by part for these pieces, this part right here, okay? And then So look like I'm gonna encounter a loop where I will have to integration by part of this again. However, the right hand side expression right here is just our left hand side. So I can actually combine like term by adding 4/9 integral of this on both sides. So I will have 4/9 e3x sine 2x dx 4/9 integral of e3x sine 2x dx. So 1 plus 4/9 is 13/9 integral of that. You can also label it at I, so you don't have to copy the expression again, and again. Okay, but since I already doing that, so I'm gonna keep this. And I have 1/3 e3x sine 2x minus 2/9 e3x cosine 2x. And this expression is gone. So now all I have to do is multiply 9/13 on both sides. 9/13, 9/13. And turn out finally our integral e3x sine 2x will equal to 9/39 e3x sine 2x minus 18/117 e3x cosine 2x. And don't forget to do plus c. That is our integral ration by part. All right.